Hi everyone. Today we're going to study angles, particularly the angles in standard position, also degrees and radians. Let us define an angle. An angle is the union of two rays having a common endpoint. The endpoint is called the vertex of the angle, and the two rays are the sides of the angle. In the figure, the two rays are here, the ray D and ray F. The point E is the vertex, that is the common endpoint. This angle is named angle. This symbol is used to denote an angle. So this is angle DEF. Greek letters or sometimes capital letters are used to denote an angle. The symbol theta is used. Also the symbol phi. This is alpha. And the symbol beta. The symbol gamma. The capital letters A, B, C, and so on. Let us draw now the angles in standard position. Think of two horizontal rays lying on top of one another. Leave one ray fixed in place and rotate the other. I have here the figure. The fixed ray is called the initial side. The rotated ray is the terminal side. The vertex is somewhere here. And we can see the amount of rotation as shown by this arc with an arrow showing the direction of the rotation. Let us define positive or negative angles. If the terminal side is rotated in a counterclockwise direction from the initial side, the angle is said to be a positive angle. In our figure here, the initial side is fixed horizontally, then the terminal side is rotated on a counterclockwise direction. The angle formed here is positive. If the terminal side is rotated in a clockwise direction from the initial side, the angle is said to be a negative angle. Let us define measure of angles. The measure of an angle is the amount of rotation from the initial side to the terminal side. There are two measures here that we will consider. The first is degree. Second is radian. Let us start with a definition of degree. 1 degree is 1 over 360 of a circular rotation. So a complete circular rotation contains 360 degrees. An angle measured in degrees should always include the unit degrees after the number. The symbol is like a small exponent 0 after the number. We have an example here, 90 degrees. Let us define now radian. 1 radian is the measure of the central angle of a circle such that the length of the arc between the initial side and the terminal side is equal to the radius of the circle. Look at this figure. This is our radius. and this arc subtended by this angle is equal to the radius itself. So the angle here is equal to 1 radian. A full revolution that is equal to 360 degrees equals 2 pi radians. Consequently, a half revolution that is equal to 180 degrees equals pi radians. More so, the radian measure of an angle is the ratio of the length of the arc subtended by the angle to the radius of the circle. Take note, when an angle is described without a specific unit, it refers to radian measure. Example, angle of 2 units. This means this 2 is in radian measure. Today we're going to study types of angles. Let's start with right angle. It is an angle that measures exactly 90 degrees. Here is a picture of a right angle. For a right angle, there is a special symbol that denotes a right angle. That small square on that corner there, that means this angle here is 90 degrees. The next angle is acute angle. It is an angle that measures between 0 degree and 90 degrees. This is a picture of an acute angle. Some examples of acute angles are 30 degrees, 45 degrees, and 60 degrees. The next angle is called straight angle. It is an angle that measures exactly 180 degrees. Here's a picture of a straight angle. It looks like a straight line, that's why the name is straight angle. The next is obtuse angle. It is an angle that measures between 90 degrees and 180 degrees. This is a figure for obtuse angle. Some examples of an obtuse angle are 100 degrees, 120 degrees, and 150 degrees. The next is 1 revolution or full rotation. It is an angle that measures exactly 360 degrees. Here's a picture of 1 revolution or full rotation. In this angle, the initial side and the terminal side coincide. Another angle is the reflex angle. It is an angle that measures between 180 degrees and 360 degrees. Here is a picture of a reflex angle. Some examples of reflex angle are 200 degrees, 270 degrees, and 300 degrees. Now let us have types of groupings of angles. The first group is complementary angles. These are 2 angles whose sum is 90 degrees. Some examples of complementary angles are 45 degrees and 45 degrees. Another pair is 60 degrees and 30 degrees. Another pair is 80 degrees and 10 degrees. The next group is supplementary angles. These are two angles whose sum is 180 degrees. Some examples of supplementary angles are 90 degrees and 90 degrees. Another pair is 100 degrees and 80 degrees. Another pair is 170 degrees and 10 degrees. We can see that the sum of each pair of angles is 180 degrees. Today we're going to study conversion of degrees to radians and vice versa. Our formula will be here, but to start with, we know that 180 degrees equals pi in radians. From this equation, we can deduce a formula that is degrees over 180 equals radians over pi. This will be our working formula in converting degrees to radians and vice versa. Let us have example 1. Convert each degree measures to radians. Letter A, 15 degrees. Letter B, 420 degrees. Let us begin with the 15 degrees. First, I'm going to write our working formula here. And then, to convert our 15 degrees into radians, we will use this formula. We will copy this again, but for this portion of degrees, we're going to write the value 15. So we have now 15 over 180 equals radians over pi. And then we will simplify from here. We will cross multiply this pi on the left side. So this will be multiplied to 15. We have now here 15 pi over 180 equals the radians will be alone on the right side. Simplifying this further, we're going to divide by 15 the numerator and denominator of the left hand side. So the 15 divided by 15 will be 1. It is not written anymore. And then we just copy the pi down here over the 180 divided by 15 is 12 and equals the right hand side, which is radians. So we have now this value pi over 12. We can simply interchange the position of the radians and the value pi over 12. To conclude, the 15 degrees equals pi over 12 in radians. This is our final answer. Let's have letter B. Convert this 420 degrees in radians. The same idea. I am going to copy this formula and then we will substitute the 420 for the degrees portion here. So it will be like this. 420 over 180 equals the right hand side radians over pi. Simplifying further, we're going to cross multiply this pi to the left side So the pi will be multiplied to the 420. We have now 420 times pi over 180 equals, the radians will be alone on the right side. Simplifying further, we're going to divide by 60 the numerator and the denominator of the left hand side. So 420 divided by 60 is 7. Then we will copy the pi down here over the 180 divided by 60 is 3 equals the radians. So we have now this value 7 pi over 3. That is our answer. We can just simply interchange the right hand side with the left hand side member. So we have radians equals 7 pi over 3. It means our 420 degrees equals 7 pi over 3 in radians. This is our final answer. Let us have example 2. Convert each radian measure to degrees. Letter A, pi over 6. Letter B, 2 pi over 5. Let us write again our working formula, and then let's begin with letter A, the pi over 6. We're going to write again this formula, but on this portion of the radian, we will substitute the value pi over 6. So we have now here degrees over 180 equals that value pi over 6 all over pi. In the right hand side, we have a complex fraction. We have a fraction in the numerator and the whole number pi in the denominator. Let us simplify this complex fraction. The pi being a whole number, we know that there is a denominator of 1 here. So let us simplify the complex fraction by doing this pi over 6. Then times, we're going to flip the pi into 1 over pi. And then from here we will simplify further. We can see that we can cancel the pi and the pi in the numerator and denominator respectively. When we do that, the right hand side is simplified into 1 over 6. From here, we're now to cross multiply this 180 to the right hand side. So the 180 times 1. And the degrees will be alone on the left hand side. We have now 180 times 1 all over 6. Since this is a factor of 1, we can simply remove this 1. We can now simplify this into 180 over 6. And when we get the quotient, the answer will be 30. Of course, we will not forget the symbol for degrees. We will put that small o exponent to denote degrees. So our answer here is 30 degrees. To conclude, the radian pi over 6 equals 30 degrees. This is our final answer. Let's have the letter B, the 2 pi over 5. Again, we will copy this formula, and on this portion of the radian, we're going to substitute that value 2 pi over 5. So we have now degrees over 180 equals the 2 pi over 5 all over pi. Then we will simplify. We have here a complex fraction. So we will have to write it again into the 2 pi over 5 times we will flip this pi into 1 over pi. And the right hand side, we can now cancel the pi and the pi respectively. When we do that, the right hand side becomes 2 over 5. To simplify further, this 180 now, we will cross multiply to the right hand side. It means it will be multiplied to the number 2. So 180 times 2 all over 5. And the degrees will be alone on the left hand side. Simplifying further, the 180 times 2 is 360. Again, the denominator 5 is there. And 360 divided by 5 equals 72. We will now affix the degree symbol. So our answer is 72 degrees. To conclude, the radian 2 pi over 5 is equal to 72 degrees. This is our final answer. I hope you learned something from this video. See you again next time.